Hi, I'm Alison Lee from Group 3, and I'm working with Evan Godo and Jonathan Lee. This video is a how-to guide for the Wilcoxon rank sum test. The Wilcoxon rank sum test is used when comparing two or more independent samples. You can also use this test in substitution of the t-test when you're not confident of the population being normally distributed. The limitation of this test is that the data should be more than the ordinal level. Before we get into the calculation, based on the question asked or analysis you wish to perform on the dataset, specify your hypothesis and desired level of significance. Using the 5% of significance level and the hypothesis, we created H1 and H0. You can calculate a Z critical value using the norm.Sn function with the probability of 0.95, and you can get 164. Using your dataset, create a grand sample by merging the data into one column. Keep track of which sample its data point came from. Do this by adding a meaningful letter beside each point. For our case, we assigned U for UVic students and C for commencement students. Sort your data in order of highest to lowest. Don't worry about the samples being out of order for the time being. Then rank your data, starting with the highest number, assign data value of 1, and continue advancing through the sample, assigning each one with a rank 1 greater than the last. The next step is to highlight the duplicate data points. You can go to under the Home tab, click the drop-down arrow for conditional formatting. Then click the highlight cell rules and duplicate values. In the event of duplicates, replace the corresponding rank of duplicated range with an average of the values. Once the ranks have been reclassified, resort the data based on the indicator you used to differentiate the two samples. For our case, it should be the score. Separate the ranks from the original sample data and side by side, group them by their original sample indicator with the score. You are now ready to begin calculating. The value for W is the sum of the ranks of your first sample. For our case, it should be the sum of the ranks of cubic students. Find the number of observations in sample 1 to calculate N1. You have to also find the number of observations in sample 2 to calculate N2. To make the Excel calculation easier, determine a value for N1 plus N2 plus 1 as well. Using this calculated value of W N1, N2, N1 plus N2 plus 1, you can calculate it as sample using a formula and here, or you can refer to the first page of our handout. To calculate the p-value, use the Excel function norm.s.distribution with the z-sample score we got. Please remind that which tail you are testing for. Use a 1 minus for the right tail test. Based on either the p-value or z-sample, either reject or fail to reject the null hypothesis and determine an answer to the question asked or analysis desired. For our case, Our decision rule was to exactly know if that sample is greater than 1.64, but the sample score is 0.72, which is much less than the set critical value. Also, the p-value is 0.23, which is greater than 0.05 of our significance level. So there is insufficient evidence to conclude that students at UVic have a higher GPA than commercial students do.